So I don't know about you, but when I look at these problems, I'm looking for the easiest way to find the derivative. So when I look at number 7, the first thing I think is, shoo, I don't want to have to do any multiplication rule. If I can already distribute and simplify that top, I'm going to do that first. So when I distribute, of course, I get this, 6x squared. And I go, wait a second, hold up, snap. Both of those terms are really being divided by x. So it really means this. Right. And I can simplify that. I go, oh my gosh, those are going to cancel out, and I get negative 9/7. And this is going to simplify, and I'm going to get 6/7 x. Wouldn't it be so much easier to take the derivative of that? I think so, because the derivative of the constant piece is just 0, and the derivative of this, well, let's see, if I power down, I'm going to get 6/7. X to the 0 is still 1. Oh my gosh, I'm all done. Wow, it's all about me. I'm taking the easiest route. As a matter of fact, I look at this one and go, Torres, seriously, are you for real, girl? Because this is really 9/5 x to the negative 2. I already know how to do this. Why are you trying to trick me? So I'm going to power down. So that's going to give me negative 18/5. And then remember, decrease the power by 1. That'll take it down to a negative 3. Got to take it down a notch. And, excuse me, if I don't want the negative exponent, well, I'll just put the x cubed on bottom with the 5. And ta-da! Why are you trying to make them look all tricky and scary, Torres? Didn't fool me. So were you thinking that on the next one too? Oh yeah. So both of those are being divided by 6. So that really turns into 1/6 x squared plus, that is a squared, not a cubed, plus 3/6 x, but that's really just a half x. And then I take the derivative, and I'm going to power down each term. So let's see, 2 times a 6th, pretty sure that's 2/6, which is going to turn into 1/3, and then my exponent is now down 1, plus, power down, 1 times a half is a half, and of course x to the 0 is still 1, so I don't need to write x to the 0 ever, and so there's my derivative. My goodness, it was way too simple, Torres. You're trying to make these all tricky. They're not tricky. To which I respond, fine, I'll kick it up a notch, because I'll put a trig function in there, which will make you crazy. So of course on this one, I see I have 2 separate terms joined by a subtraction, so I can do them individually. So the derivative of this, when I power down, is just going to be 1, and then minus, because I'm just going to continue that down, and then the derivative of tangent is secant squared. And that's it, unless I go, oh wait, 1 minus secant squared, I think that's a trig identity. Oh yeah, 1 minus secant squared, that's negative tangent squared. If you remember, I tan in a second. Remember my cute little way to remember these? So let's see, if I move secant over and tangent over, they both become negative, and I'd end up with this. Now, the reason you'll want to know that is if you get a multiple choice and you know for sure, and you've banged your head off the desk a couple times, you know for sure this is right, you are going to have to look for something that is equivalent. That might be the multiple choice versus this one was not there. So just FYI, you always got to be on the lookout. And on this next one, since it's a product, I've got to do first times derivative of the second, but derivative of secant is secant tangent, plus second, so secant, times derivative of the first, but derivative of the first is just going to be 1. And so when I simplify, I get that, so nothing really changed. And they might switch it up a little and go, hey, you could factor out a secant, and we're going to try to trick you and put that as the multiple choice. So just know that either one of these is correct.